Hello, everyone. Welcome to class today. We are going to go over 28A today. So we've got some word problems. So let's go ahead and attack these. Okay, so the first one says Justin has 7 coins in his pocket. They are all either nickels or dimes. So if the total value of the coins is 45 cents, how many of each kind does he have? Okay, so we know, let's go ahead. Reading this one word problem, we're going to be able to get 2 equations. So we know that he has 7 coins in his pocket, and they're either nickels or dimes. So we know that the number of nickels plus the number of dimes is going to equal to 7. Okay? If the total value of the coins is 45 cents. So, what is the value of a nickel? So that's going to be 5 cents. So 0.05 nickels plus, and then what is the value of a dime? 10 cents, right? So 0.10 dimes equals, so how many nickels I have times 0.5, and then how many dimes I have times 0.1, that's going to equal 45 cents. So 0.45. How many of each kind does he have? So we have all the information we need to solve this. So I want to solve for one of these equations and then plug it into the other equation. And there's actually a lot of ways to do this. So I'm just going to show you one way, but there are several ways to do this. So there's several correct ways to solve the equations. So whatever way you decide to do it, that's okay. I'm going to show you one way. So one thing you could do is you could multiply everything by 100. So that would give me 5 nickels plus 10 dimes equals 45. And then I could multiply this equation by -5. So -5n minus 5d equals -35. And you add those together, and then the nickels would cancel out, and you could solve for dimes. So that's one way to do it. I'm actually going to do it a different way. So I'm going to take this first equation, and I'm going to solve it for n. So n equals -d plus 7. So I just took d and I subtracted d over, and I get n equals -d plus 7. That tells me that n equals, you could say 7 minus d or -d plus 7. Either way is fine. So I'm going to take this thing that says I say that this equals n, and I'm going to stick it into this equation. So I'm going to rewrite this equation with this stuck inside. So 0.05 times, now I'm not going to write n because I'm substituting this stuff in for n, -d plus 7 plus, and I'm just continuing on writing my equation, 0.10d equals 0.45. And now that I'm looking at this, I'm actually starting to think that I do want to multiply everything by 100 because it's going to give me whole numbers to work with instead of decimals. So in math, I can multiply any equation by whatever I want, as long as I do it to every single term and I do it to both sides of the equal sign. So I'm just going to go ahead and multiply everything by 100. So that's going to give me 100 times 0.5 is just 5.05. I said that right? So 5 times -d plus 7. So remember, this is all one term because terms are separated by pluses and minuses. And then 100 times 0.1 is 10. So plus 10D equals 45. Okay, so it's a little less messy because now I don't have any decimals to deal with. I just have whole numbers. So 5 times negative D, I'm just going to bring it up here. Negative 5D, and then 5 times 7 is plus 35. And then I have plus 10D equals 45. Okay, so now I can combine like terms, right? I can combine the D's, so that 10 minus 5 gives me 5D. And then I subtract 35 over 45 minus 35 is just 10. And then I'm going to divide by 5. So I have D equals 2. Okay, so I know what D is. I know I have 2 dimes. So I'm going to stick D into this first equation. So I have N equals, so I'm going to circle D because that's one of my answers. Stick D into this equation. So I have N, oh, not equals. Well, I could stick it in here, but I'm just going to stick it in my original equation. It's really best practice to do that, just so we don't make any mistakes. So N plus 2 equals 7. That means N, right? We got to subtract 2. 7 subtract 2 is 5. Another way to think about it is something plus 2 is 7 is 5, right? Our brains can do that pretty fast. So N equals 5. So how many of each kind does he have? I have 2 dimes and 5 nickels. All right. So pretty simple, right? And if you wanted to double check, make sure that was right. Nickels are 5 cents. I have 5 of them. It means I have 25 cents. And then I have 2 dimes, so that's 20 cents. So 20 cents plus 25 cents is 45 cents. So these are pretty simple. We're just solving what's called systems of equations. So we're going to have 2 equations, usually 2 unknowns, and then we're going to solve them. In math, we want to make sure that we have the same number of equations as we have unknowns. So what's not coming in this course, but may come up in other math courses you take, we need to make sure that we count the number of unknowns and the number of equations and make sure they match. That way we can do the math to solve. Okay, Cameron has nickels and pennies. Okay, so this is going to be really similar, right? If the value of his 24 coins, okay, so I can already write down one equation. I have nickels and pennies, and they're going to equal 24. So my nickels plus my pennies equals 24. All right. If the value of his 24 coins adds up to 56 cents, how many of each kind does he have? So really similar to this first one, right? So nickels are worth 5 cents. So 0.05 nickels. And then pennies are worth 1 cent plus 0.01 pennies equals, the value would equal 0.56. 0.56. And you know what? I'm going to go ahead and do that 100 trick just because it's going to make it easier for, we're going to get rid of all the decimals, and that way we're just dealing with whole numbers. It's just easier for our brains to think about it. So multiply this whole equation by 100. I get 5n plus 1p, or if I'm a mathematician, I don't write the 1p and I just write p, correct? Equals 56. Okay, I have my 2 equations, 2 unknowns. Oh, and look, I'm going to do this a bit differently. So because I notice that I have 1p here and 1p here, and they can cancel. So I'm going to go ahead and multiply this equation by -1. So I'm going to take this first equation over here, n plus p equals 24. And then underneath, I'm going to write this one, but I'm going to multiply by -1. -1 times 5n is -5n. -1 times 1p, or just p, is -p, or minus p, equals, and then -56. Okay, now I can go ahead and just add those equations. So I get n minus 5n is negative 4n. And then I get p minus p, which is 0. I don't need to write 0. I can just leave it blank, equals. And then I have 24, positive 24, minus 56. So the signs are different, so we subtract. So 56, so 6 minus 4 is 2. 5 minus 2 is 3. And the bigger number gets the sign. So 56 is negative, so this must be a negative number. Okay, great. So now we're going to divide by negative 4 on both sides. Divide by negative 4, divide by negative 4. I get n equals negative divided by negative is a positive. 32 divided by 4 is 8. So that's my first unknown. So I know I have 8 nickels. Now, how many pennies do I have? I want to go back to the simplest equation. Both of these equations will work, but one of them is a lot simpler than the other one, and that's this one. So 8, because I'm just substituting in my value into my unknown because now I know that value, plus p equals 24. So p equals, and we're just subtracting 8 on both sides, right? Super simple. And that gives us 16. So that means I have 16 pennies and 8 nickels. Now let's just do some quick math in our head just to make sure that we check our work. So if I have 8 nickels, and nickels are worth 5 cents each, that means I have 40 cents. So I have 40 cents there. And then pennies are worth 1 cent, so I have 16 cents there. 16 plus 40 is 56. So yes, I did everything correctly. These are really fun, right? Are you having a good time? To math people, these are really fun, and I really hope that you start enjoying them. Okay, so it looks like this one is really similar. I love it if you just pause the video and try to figure this one out on your own. That's how you should always approach these problems that I do with you, is do one with me and then pause the video and see if you can figure out the next one. So this would be an excellent one that now you know the format to solve these problems. You could probably figure out this next one on your own and then watch my solution to see if you get the same answer. Nicole has a total of 11 quarters and dimes. Okay, so quarters plus dimes equals 11. If she has $2.15, how many of each coin does she have? So quarters are worth 25 cents. And dimes are worth 10 cents. And then that equals $2.15. Now I want to multiply by 100, and I'm actually not going to draw 100 out here. I'm just going to do this in my mind. We've done it a couple times, so you should be able to pick up and see the pattern. Remember, math is really all about seeing patterns. So we have 25Q plus 10 dimes equals 215. Okay, that looks great. We've got our two equations. And with this one, I am going to do substitution. So I'm going to take this first equation and rewrite it a bit. Q equals 11 minus D. Again, you could write Q equals negative D plus 11. You could have actually solved for D and said D equals 11 minus Q, or negative Q plus 11. All of those are right. So there's at least 4 different ways to solve this equation. Also, if you do the other way, where we're going to multiply something here and cancel it out like we did up here, then there's even 4 more ways to solve the equation. So already in my mind, I can think of 8 ways to solve this equation. So there's lots of ways, as long as you did everything algebraically correctly and you got the right answer at the end, you probably did it right. Okay, so this is the way I'm going to do it. I'm going to stick this in for Q. 25 times 11 minus D plus 10D equals 215. 25 times 11. So whenever we multiply by 11, we just do 25 and 25. We just offset them. That's the shortcut trick. So I've got 275 minus 25d plus 10d equals 215. Okay, so now I've got some like terms here. Negative 25d plus 10d is negative 15d. I ran out of room, so I got to hop up here. And then I'm going to subtract over 27, 275. So positive 215 minus 275 is what? So we subtract them, right? They're different signs. We subtract them, and the bigger number gets the sign. So 275, so the 200s go out, right? 75 minus 15 is 60. So negative 60. And then I divide by negative 15. And I haven't memorized all my times tables, but I know that 15 times 2 is 30, and that times 2 is 60. So I know that 15 times 4 is 60. So D equals positive 4. Okay, so now I just need to bring it up into, I could use this equation or even this massive equation, whichever equation you want to do. Q equals 11 minus 4, and then Q equals 11 minus 12 minus 4 is 8. That means 11 minus 4 is 7. Is that correct? 10 minus 3 is 7. Yes, so 7. Great. And I'm just going to put Q over here just so I really shouldn't do this in math. I should have written it underneath, but I ran out of room, so I'm just going to sneak it right here. Now, does this make sense? I've got 7 quarters. So that's almost $2, but not quite. That's $1.75. And then I've got 4 dimes. So $1.75, and then plus 2 dimes is $1.95, plus one more dime is $2.05. And then another dime is at $2.15. So yes, I did in my head really quick, and I am correct. So great. All right. Find 3 consecutive integers such that 2 times the first integer plus 3 times the second integer minus the third integer is equal to 21. So all we're doing in math a lot of the time with these word problems is we're just translating. We're translating from the English language to the math language. And that's really what we're doing here. Okay, so they are 3 consecutive integers. So the first could be a number, but the second integer is that number plus 1. It is like another number, but it has a relationship. And we want to describe the relationship in math terms. So that's going to be n plus 1. Now, the third consecutive integer is actually going to be this integer plus 1. So n plus 1 is n plus 2. So that is the trick for these consecutive integer problems. We don't just want to name it the first, the second, the third, because they're more than just 3 unknowns. They're actually consecutive. So we actually have to describe the relationship through math when we solve these problems. Okay, now we're going to read a sentence and translate it from English to math, which can be really fun. Okay. 2 times the first integer. Okay, so that's 2 times n, right? 2 times the first integer plus 3 times the second integer. So here's the second integer, and we're going to go 3 times the second integer minus the third integer. So minus, okay, the third integer and nothing times it. It's just the third integer. So I actually don't need these parentheses. Oh, I have a minus. Yes, I do. Okay. So plus minus n plus 2 because we actually have to distribute this negative into the n and to the 2. Okay, so that was tricky. That we almost fell into a pit there, but we saved ourselves right there. Okay, is equal, right? That's very simple. 21. Okay, so I want you to think. Remember I said that we need to have the number of equations equal to the number of unknowns. So how many equations do I have? Just one, right? And then how many unknowns do I have? We actually have only one unknown. So I'm good. I actually don't need another equation here because we have a relationship between all three unknowns. Okay, so we're going to go ahead and just algebraically go through this. This should remind you of Algebra 1. Super simple problem. We're just going to solve. So 2n plus 3n times 3, right? So 3n plus 3 times 1 is 3. And then negative n minus n, negative times 2 is negative 2 equals 21. All right, let's combine like terms here. How many n's do we have over here? So 2n plus 3n minus n. Okay, so 2 plus 3 is 5 minus n, that's 4n. So I've got 4n, and that's a positive. Okay, I've got positive 4n. Now, how many numbers do I have? I have 3 minus 2. Okay, so I just have 1. So 1 equals 21. Okay, I'm going to go ahead and subtract that 1 over to the other side. Minus 1, 4n equals 20. And then divide by 4, divide by 4. So I get n equal to 5. All right, so I am not done yet because I need to know what my first consecutive integer is, what my second consecutive integer is, and my third consecutive integer. Okay, let's see what these are. So I get, okay, so my first consecutive integer is 5. And then what's my second one? 6. And my third one? 7, right? So this is actually my answer, 5, 6, 7. This is actually not my answer. If I were the homeschool parent and my child had just circled n equals 5, this question would be marked wrong because they actually didn't answer the question. Find 3 consecutive integers. So this right here, 5, 6, 7, is the correct answer. Okay, let's go to the next page. I like these. These are really fun. Find 3 consecutive even integers. Okay, I really want you to think. So here's first, second, third. Okay, I want you to think. So I'll give you the first hint. The first one is going to be n, but what would be my second integer? Now, they need to be consecutive, but now they need to be even. So how would I ensure that these integers are going to be even? All right, so hopefully you paused the video and you thought about it just a little bit. Okay, so how we make them even, if we think of 2, the next consecutive even integer is 4. So we can get from 2 to 4 by adding 2 or by multiplying by 2. So I want you to think, which one are we going to do? Are we going to add 2 or multiply by 2? And hopefully you said add to, because if we multiply, that works from 2 to 4, but that does not work from 4 to 6. So 6 would be the next consecutive even integer. And we get from 4 to 6 by adding 2. We get from 6 to 8 by adding 2. We get from 16 to 18 by adding 2. So we need the consecutive integers. Okay, so we're going to do n plus 2, and then the third integer is this plus 2. So we're actually getting n plus 4. Okay, now all we've got to do now is we're just going to translate from English to math, such that 8 times the first integer, okay, super simple, 8n minus 2 times the third integer, 2 times the third one. Okay, 2 times the third integer, all right, equals 10 plus the second integer. Now I want you to think, why did I not need parentheses there? Because it's not being multiplied and it's being added. So I don't need to distribute the negative. So I can just leave the parentheses off there. If you added the parentheses, it's not wrong, but just the next step, you would remove them. Okay, so let's go ahead and solve this equation. Remember, we have one equation, but we only have one unknown. Okay, so we have 8n. I'm going to move this over a little bit. Negative 2 times n is negative 2n. Don't forget that negative. Negative times a positive is a negative. 2 times 4 is 8 equals 10 plus n plus 2. All right, I'm just going to go ahead and do that 10 plus 2 step on this side. So I have 12 plus n. So remember, just like we learned in algebra, we want to get all of our numbers to one side and all of our letters to the other side. And it doesn't matter which one you do. So 8n minus 2n is 6n, but now I'm going to subtract this n over there as well. So 6n minus 1n is 5n. And then I have 12n, and then I'm going to move this negative 8 to the other side, which means I need to add that 8. So 12 plus 8 is 20. And then I get n equal to 4. And remember that last step, you can think of it two ways. You can say, okay, I need to divide by 5 on both sides. That would work. You can also say 5 times what equals 20, and that's going to be 4. So remember, you can always think about it two different ways, and you pick the way that makes most sense to you. Okay, and I know some of you are super brains. I just want to put this out there. So the only reason why you show your work is so that teachers know you're not cheating. But if you can go from this step to this step, just all in your brain, feel free to do that, because that is actually more efficient and better for you. So that's okay as long as you can talk through all of the steps. Teachers just don't want you, including homeschool parents, we just don't want you to cheat. We really want you to think about it in your brain and make sure that you're getting the right answer. Okay, so is this my answer? Good. I hope everyone said no. I need to plug it in up here and find all of my consecutive integers. Now, the first thing I ask, is this even? Yes. So it came out evenly, so that's good. N equals 4. That means n plus 2 would equal 6, and n plus 4 equals 8. So these are my answers. So great job. Okay, now I need 3 consecutive odd integers. Okay, so now I have odd integers. So the first one is going to be what? It's going to be n, right? I'm just thinking about, how do I get odd integers? So how do I get from 1 to 3? How do I get from 3 to 5? How do I get from 5 to 7? Right? And I hope you're saying just add 2, right? That's what we're going to do. And notice how similar it is to the even integers. It just all depends on where we start. Okay, the second is going to be n plus 2, while the third is going to be n plus 4. Super, super simple. So now all we have to do is translate English into math. Okay, 3 times the first integer, okay, 3 times the first, plus 4 times the second, equals 13 times the third, oh, negative 13. Oh, okay. Negative, they put those parentheses, they didn't have to, but they put it there to draw your attention. This isn't just 13, this is negative 13. Negative 13 times the third integer. Okay, great. So now we're just going to, remember we have one unknown, one equation we can solve now. So we have 3n plus 4n plus 8 equals negative 13n. And I don't know my 13 times tables. Some people memorize those. I did not. So I'm going to do a negative times a positive is a negative. And I'm just going to write this out on paper just because it's easier for me. So I have 10 times 4 is 40. And then I have 3 times 4 is 12. So if don't be scared by the bigger numbers, you just separate it out like that. That's totally fine. Okay, looks good. Now we're going to combine like terms. 3 plus 4 equals 7n. And plus 8. I was gonna skip some steps, but it's okay. I think I'm gonna show all my steps. Negative 13n minus 52. Negative 13n minus 52. Okay, that looks really good. Now I'm going to get all my letters to one side, all my numbers to one side. So plus 13n. Oh, that's easy. It's going to be 20n over here, right? And then negative minus 8. So negative 52 minus 8 is negative 60. Okay, that looks pretty good. Okay, so now I'm going to divide both sides by 20. I can already I've got 0 over here, 0 over here. I can X those out. And then I get negative 6 divided by 2 is negative 3. Negative 3. Okay, and that is not my answer. I want to know the first consecutive integers. So I have negative 3, and then negative 3 plus 2 is negative 1. And then negative 1 plus 2 again, or I could say negative 3 plus 4 is positive 1. So these are my 3 consecutive integers, negative 3, negative 1, and 1. Great, so that looks good. Okay, we get to do some percentages now. The baker has a mixture of 80% wheat flour and 20% oat flour. He also has a mixture that is 90% wheat and 10% oat. For his new recipe, he needs 10 pounds of a mixture that is 85% wheat flour. How much of the original mixtures does he need? So this mixture one plus mixture 2 needs to add up. So some poundage of mixture 1 plus some poundage of mixture 2 will need to equal how many? How many poundage? So 10. But it matters to me how much of mixture 1 and how much of mixture 2. Okay, so we've got our first equation. Now for our second equation, what's important to note is we don't care about the oat flour. All we care about is the wheat flour. So if I take mixture one and I'm going to add 80% of that wheat flour. So 80, and I'm going to multiply that by the amount that I'm adding on mixture one. Plus, I'm going to take the wheat flour of mixture two, and that's 90% of mixture two. I'm going to add those together, and I'm going to get 85% of the poundage. Now I have to think, what is that poundage going to be? It's not a variable. It's actually this one, this thing right here. It's actually 10. It's going to be 85% multiplied by the number of pounds. So remember, this is 80% multiplied by the number of pounds plus 90% multiplied by the number of pounds. And I need 85% multiplied by the number of pounds. And the number of pounds that I end up with is 10. Okay, now you can solve this a bunch of different ways, just like we discussed before, but I like starting with a simple equation and solving for one variable and sticking it in somewhere else. So we have mixture one equals 10 minus mixture two. Okay, so I'm going to take this and I'm going to substitute it in for mixture one. 80 times 10 minus mixture two plus 90 mixture two equals 850. So if I take 90 parts of mixture one and I take 80 parts of mixture one and then I add 90 parts of mixture one, I'm going to get 85 parts of 10 pounds of flour, or 850. So 80 times 10 is 800. 80 times negative mixture two is minus 80 M2 plus 90 M2 equals 850. So 90 minus 80, that's going to be 10. I'm going to jump up here because I've run out of room. 10 mixture 2 equals, and then subtract 800 over 850 minus 800 is 50. And then mixture 2 is equal to 5. So I'm going to use 5 pounds of flour for mixture 2. So I'm just going to hop this into my equation up here. So mixture 2 equals 5. Mixture 1 equals 10 minus 5. And then mixture 1 equals 5 as well. Okay, so how much of each of the original mixtures does he need? He needs 5 pounds of mixture 2 and 5 pounds of mixture 1. All right, a chemist needs 65 milliliters of a 9% acid solution. He has on hand a 10% acid solution and a 1% acid solution. How many milliliters of each should he use? So this is really similar. So we need 65 milliliters. So solution 1 plus solution 2 equals 65. Then I need to make sure that I put in the right percentage amounts of the solution. So solution 1 is 10%. So 10 of solution 1 plus 1, and remember, you don't have to write the 1, but 1 of solution 2 should equal 9% of the 65 milliliter solution. Okay, that looks good. Let's go ahead. And so this one, I have 1 here and a 1 here, so they could cancel. I'm going to go ahead and multiply by a -1 by each of these terms so I can get one of those to cancel. So solution 1 plus solution 2 equals 65. So I have negative 10 of solution 1 minus solution 2 equals 9 times 65. And we're just doing quick math over here. 45, 9 times 6 is 54, plus 4 is 58. 58. So 585. All right, and we're going to go ahead and add these two equations. So solution 1 minus 10 solution 1 is negative 9 solution 1. The solution 2 minus solution 2 is 0 equals 65 plus 585. So 5 plus 5 is 10. 6 plus 8 is 14. 14 plus 1 is 15. And then 1 plus 5 is 6. Divide by negative 9 on both sides. Oh, you know what? I forgot. I forgot when I was multiplying by my negative, I forgot to make that one negative as well. So we have 585 minus 65, okay, which is 520. And then it's negative 520 divided by negative 9. So solution 1 equals, and I'm going to do some long division over here, 520 divided by 9. 5 times 9 is 45. And 12 minus 5 is 7. And then bring the 0 down. 9 goes into 77 times, and we get 63. And then 7, so it's going to be 0.7, and it's going to repeat. So we can round it to 57.78 milliliters. And solution, that's going to be solution 1. And then I'm going to stick it back in my equation. And I'm going to use, just use that equation. So I have solution 2 equals 65 minus 57.78. But I have to borrow a bunch. And gives me 2.7. Oh, I don't know what I wrote 4 there. I meant to write 5. All right, so solution 2 is going to be 7.22 milliliters. Okay, so this is my final answer. So if I want a 65 milliliter solution of 9% acid, then from solution 1, I need 57.78 milliliters. And from solution 2, I need 7.22 milliliters. And then it's also helpful to designate which one is which. So solution 1 would be the 10% acid solution. And solution 2 is going to be the 1% acid solution. And it would make sense that I would need more of the acid solution because 10% is really close to 9. I just need to dilute it just a little bit. And so that would make sense that I would use mostly the 10% acid solution and a little bit of the 1% acid solution. Okay, that is it for today. I hope you enjoyed this worksheet with me, and I will see you next time. Bye.